Welcome to This Explainer. Today, we're diving deep into the crushing, turbulent depths of the solar system's largest planet. We're going to uncover a real scientific detective story, a massive mystery hiding at the very center of Jupiter that completely upended our understanding of how planets actually form. Section 1, the deepest planetary mystery. So let's kick things off with a pretty wild question. Is Jupiter actually hiding a shattered world inside it? You know, for decades, scientists just had to treat the very center of Jupiter as an unsolvable black box. Sure, we can easily look through telescopes and see its beautiful swirling outer clouds and massive storms like the Great Red Spot, but what actually lies thousands of miles beneath all that? Well, to understand why it's been such a profound mystery for so long, we really have to wrap our heads around the incredibly extreme environment deep inside. Down at its deepest depths, the pressure hits a staggering 10 megabars. To put that into perspective, that is roughly 10 million times the atmospheric pressure you and I feel walking around right now on Earth. 10 million! It's an extreme high-pressure environment so violent that sending a physical probe is absolutely impossible. The strongest submarine humanity has ever built would be instantly crushed, like an empty soda can way before it ever got close to the core. Now throw in blazing temperatures of around 10,000 Kelvin, which, by the way, is actually hotter than the surface of the sun, and you get this completely bizarre environment where matter itself just breaks down. Under these conditions, the hydrogen gas that makes up most of Jupiter stops acting like a normal gas at all. Instead, it transitions into this churning, super dense, metallic fluid. It's wild. Moving on to Section 2, the classic core assumption. Since we literally couldn't just look inside, early scientists had to rely heavily on planetary formation theories to guess what was hiding in the dark. For a long time, we essentially had a showdown between two dueling theories. The first was core accretion. This suggested that Jupiter built a dense, solid, rocky and icy core first, which then acted like a giant gravitational vacuum, sucking up a massive envelope of gas around it. The alternative was direct collapse, where the planet formed straight from a collapsing cloud of gas, meaning it would have absolutely zero solid core, just a giant swirl of gas getting denser and denser toward the center. Ultimately, the scientific community leaned pretty hard toward the core accretion theory. As you can see, this resulted in a very neat, traditional three-layer model of Jupiter. It proposed a dense, solid central core of rock and ice, surrounded by a thick inner layer of that fluid metallic hydrogen, and finally an outer layer of molecular hydrogen and helium. It was a really clean, logical picture. But physics demands proof. How do you actually prove this model when you can't go inside? That brings us to Section 3, decoding gravity's hidden clues. To prove the model, scientists needed a way to see inside the planet without physically going there. The brilliant solution? Using gravity as a sort of planetary X-ray. Because Jupiter spins incredibly fast, completing a full turn in just 10 hours, it actually bulges out at the equator, a lot like a spinning water balloon. This rapid rotation, mixed with all the mass hiding inside, gives the planet a completely unique gravitational fingerprint. We track this fingerprint using what physicists call zonal harmonic coefficients, or just J numbers. Simply put, spacecraft measure the planet's gravitational pull on the outside to tell us exactly how the mass is distributed on the inside. By looking at the different J numbers, scientists can essentially peel back the layers of the planet mathematically. The lower numbers, like the J2 term, mostly give us the linear response, so they tell us about the outer layers. But to unlock the juicy secrets of the deep interior, scientists really need the higher order numbers, like J4 and J6. These represent the complex, nonlinear gravitational response, and they act as our primary window into the density of the deepest, darkest parts of Jupiter. Now, gathering this higher order data was definitely not an overnight success. It took half a century of gradual improvements, from early ground-based telescopes to the Pioneer and Voyager flybys in the 70s, and later the Galileo orbiter. Our measurements of these gravitational harmonics just kept getting better and better. Every single mission shrank the error bars, steadily setting the stage for the ultimate test of Jupiter's core. Which leads us right into Section 4, Juno's massive plot twist. That ultimate test finally arrived in July 2016 when the Juno spacecraft entered a highly specialized polar orbit around Jupiter. Juno was perfectly optimized to take the most precise gravitational measurements in history. And guess what? The data it sent back completely broke our existing models. Literally broke them. Juno revealed that Jupiter's core is not a solid, compact rock at all. But it's also not completely missing. Instead, it's this bizarre, fuzzy, diffuse core that is just thoroughly mixed right into the surrounding metallic hydrogen mantle. And the sheer scale of this twist is honestly hard to overstate. This diffuse, fuzzy core contains incredibly heavy elements with a combined mass ranging from 7 to a staggering 25 times the entire mass of the Earth. Just imagine up to 25 Earths worth of heavy rock and ice, essentially diluted and swirling around the center of the gas giant, rather than packed tightly into a neat little sphere. Even more shocking, this mixed-up core material isn't just a tiny speck stuck right at the center. It actually stretches outward to cover 30 to 50% of the planet's entire radius. Let that sink in for a second. Nearly half of Jupiter, the absolute largest planet in our solar system, is made up of this giant diluted core soup. So, Section 5, shattered. What happened? This massive, diluted structure left physicists completely scrambling. I mean, if the planet started with a solid core, how could it possibly look like this now? Well, this scramble led to two incredibly violent, fascinating hypotheses. The first is basically a cosmic crime scene. It suggests that a few million years after Jupiter formed with a traditional compact core, another massive protoplanet, weighing roughly 10 times Earth's mass, just slammed head-on into it. This colossal impact would have permanently shattered the original solid core, forcefully scattering all those heavy elements deep into the hydrogen envelope. The second hypothesis is just as extreme, but it operates on a much slower timeline. This is the theory of core erosion. Over billions of years, the insane temperatures and pressures at the center of the planet literally dissolved the rocky or icy core into the fluid metallic hydrogen above it. Think of it like a sugar cube slowly dissolving into a really hot cup of tea. Violent internal thermal currents then constantly dragged that heavy material upward and outward over eons. This erosion is driven by some pretty unimaginable internal weather. Deep inside Jupiter, there is a gradual transition from molecular to metallic hydrogen. But as this happens, the helium mixed within it phase separates. This creates literal helium rain, actual droplets of heavy helium falling downward through the metallic hydrogen. This incredible process, combined with deep convective currents, essentially eats away at the central core, dissolving it piece by piece over billions of years. So, whether it was shattered by a colossal planetary collision or slowly dissolved by billions of years of helium rain, one thing is for sure: Jupiter's core is absolutely nothing like the simple, solid rock we imagined for decades. And as we continue to decode the secrets hidden beneath Jupiter's swirling clouds, we have to ask ourselves a pretty provocative question. If the largest planet in our solar system was hiding a shattered core, what other fundamental laws of planetary formation are waiting to be rewritten? Seriously, what else out there are we completely wrong about? Thank you so much for exploring this cosmic mystery with me today on This Explainer.